All right, let's go ahead and do some guided practice problems with calculating pH and hydrogen ion concentration, POH, and hydroxide ion concentration. This here is a flowchart where if you are given any of these, if you're given this, or this, you can calculate any of the others. So if you're given one of those four, you can calculate any of the other four. So let's go ahead and get started. First off, it says determine each of the following as being acidic, basic, or neutral. I'm going to go through a couple of these very easy. This right here, really, all you need to do is take the negative log of that. So you do negative log of 2 times 10 to the negative 4. And that will give you the pH. Now, the reason why it gives you the pH is because you're taking the negative log of the hydrogen ion concentration. And when you do that, that's going to give you a pH of 3.698, which is about 3.70. And so this is the pH. Now again, if pH is less than 7, that's going to be acidic. Acidic is a pH of less than 7. Basic is a pH greater than 7, and then neutral is where it's equal to 7, where the pH is equal to 7. All right, so this here is acidic. All right, well again, you take the negative log of this, and when you take the negative log of that, that's going to give you the pH. Okay, so let's go ahead and do that. And when you take the negative log of that, it's going to give you a pH of 9.36, which is basic because it's greater than 7. All right, the next one, again, you take the negative log of this, but when you take the negative log of that, that's not going to give you pH, that's going to give you POH. Because what is that the concentration of? It's the concentration of hydroxide. So that's going to end up giving you a POH of 6.01 about. So is that acidic or basic? Well, remember, if we look over here, this is in your notes by the way, that pH plus POH is 14. So if we know the POH, we can subtract it from 14 to get the pH. And so that means that the pH must be about 7.99. Because when you do, because these two added together will be 14. And so that means that it is a basic solution. It's a basic solution. This one, you can just look at the pH, POH, figure out if it's acidic or basic. Go ahead and do those practice problems 4 through 9 and look at the answer key. Now, this next one, easy peasy. We're determining the pH and the POH of those. And so again, negative log of these will give us the pH. And so we have negative log 3.41 times 10 to the negative 2. That's a pH of 1.46 about, 1.47. And so for number 10, the pH is 1.47. So again, that's number 10. And the POH, well again, pH plus POH is equal to 14. And so we just need to subtract the 1.47 from 14, and we get a POH of 12.53. All right, again, these are very, very straightforward problems. If you need help with 11 through 13, just literally watch number 10 again, and then check the answer key on Schoology. All right, this next one, I want to focus on number 15 specifically. All right, so I want to focus on number 15 specifically. Number 15 is asking us to calculate the pH and the POH of that. Now, we cannot just take the negative log of this. what we need to do to that, and I really want you to pause the video, what do we need to do to this first? And I'm going to give you a hint, it has to do with the formula. The formula tells us what we need to do to that first. And what we need to do is we need to multiply it by 2. Because strontium hydroxide is a strong base, because it's telling us that. And when this dissociates in solution, it makes strontium ion plus 2 hydroxide ion. So because this is a concentration of 1.27 times 10 to the negative 3, this is going to be double whatever this is. And so we end up with 2.54 times 10 to the negative 3. And I'm going to clean that up a little bit. And so, again, because there's 2 hydroxide there, we have to pay attention to that. Now, now that we have the hydroxide ion concentration, we can take the negative log of that. And when we take the negative log of that, I'm going to ask you, does it give us the pH or does it give us the pOH? And the answer is it gives us the pOH, because that is the negative log of the hydrogen, or the hydroxide ion concentration. And we end up with a pOH for number 15 here. We get a pOH of 2.60 about. We know that pH plus pOH is equal to 14. So we just need to subtract the 2.60. And that means we get a pH of 11.4. Which makes sense because that's a basic solution and we're putting a base in there. Again, with 14 and 16, you do not need to multiply the hydroxide or the concentration by 2 because there's only 1 hydroxide ion per formula unit there. All right, this is a very similar problem to the KW problems. And then we have this one. To go from pH to hydrogen ion concentration, the formula is 10 to the negative pH is equal to the hydrogen ion concentration. And so that's our formula there. If you take a look, that's actually part of your booklet right here. Actually, it's not in there. So I will add that in class. But this is how you go from pH to hydrogen ion concentration. It's 10 to the negative pH is equal to the hydrogen ion concentration. And so what this is asking for, it's asking for the concentration of the sulfuric acid. And sulfuric acid is H2SO4. That's sulfuric acid. And what we want to keep in mind is that this also gives off 2 hydrogen ions in solution. And so whatever the concentration of this is going to be half the concentration. Because again, one of these is going to give off 2 of these. So whatever amount of this we have, it's going to be half the amount of that in terms of concentration. And the way that we find this is with this equation right here, 10 to the negative pH. All right, so let's go ahead and do that. 10 to the negative 3.2 is equal to 6.31 times 10 to the negative 4. Now this here is the hydrogen ion concentration. And again, if this is the hydrogen ion concentration, we can go from the hydrogen ion concentration to this here. We know this for every one of these, 2 of these will be produced. And so we just divide that by 2, and that will actually give us the answer to this problem here. Now, what I will say is, I want you to go to your booklet and add what I'm about to add to that little formula, those little, the box thing. But before we do that, this is the molarity of the H2SO4. All right, so that's the answer to this problem. And again, all we did was we took the 10 to the negative pH, gave us the hydrogen ion concentration. We know that whatever the concentration of the hydrogen ion is, the concentration of the sulfuric acid is going to be half of that, because there's 2 hydronium ions given off for every one of those. So I want you to go to this here, and I want you to draw an arrow going this direction here, and an arrow going this direction. So if we're going from pH to hydrogen ion, the way we go from pH to hydrogen ion is we do 10 to the negative pH is equal to the hydrogen ion concentration. And then I'm just going to write it out to the side here. 10 to the negative pOH is equal to the hydroxide ion concentration. So that's how you go from pH to hydrogen ion, and that's how you go from pOH to hydroxide ion. And if you are in Algebra 2, you probably learned about logs, so you know about log rolls and all that. And so you can actually, this equation here is the same thing as this equation. It's just rearranged to solve for hydrogen ion. So, all right, that's all I have for you. Do the other practice problems as well. Check the answer key that's on the website there, and have a great day.